Okay, so the most important thing is just to make sure that the bases are all the same. In this case, they are all base E. And so if we, I guess, look at the left-hand side, bring that 2 back into the power up here to make it an x squared. So we have natural log of x squared minus natural log of x minus 1 on the left. If we subtract natural logs, we divide the actual expression. So that's the equivalent of x squared over x minus 1. So if I have natural log of that expression equal to natural log of another expression, well, we equate, and so both expressions must be equal. So this implies that x squared over x minus 1 has to equal x minus 4. Multiply the x minus 1 across, expand the terms on the right-hand side, so I'll end up with x squared equal to x squared minus 5x plus 4. Subtract the x squared, so I end up with 5x equal to 4, so x is equal to 4/5. A habit that we have to all get into is then to check to see if that answer is feasible or reasonable in terms of the domain of the function that we're dealing with. So if we have a look at the actual log expressions we've got, natural log of x minus 1, natural log of x minus 4. For each of those to exist, we need the expression inside the log to be positive, which means the domain of that expression is x is greater than 4. So whilst x equal to 4/5 solves that equation algebraically, it's not feasible. So since x value is not greater than 4, there is actually no solution to that. All right, so that's a really important habit to get into. And actually even here, yep, that's fine. So let's go on to B. I guess there's a few ways. We're going to stick to the log laws at this point in time. So again, I'm going to bring the 3 into the x to make it an x cubed, and I'm going to turn 2 into a log expression. And since the bases we're dealing with are base 10, I'm going to make 2 times log base 10 of 10, which is the equivalent of 1. So really, I'm just doing 2 times 1. But then on the next line there, we can see I can bring that 2 into the power to make it log base 10 of 100. So on this line, I've got a sum of log expressions, which means I multiply them together. So I can write on the left-hand side, log base 10 of 100 times x cubed equal to log base 10 of x to the 5. All right, again, bringing the 5 into the power. So log base 10s, the bases are the same. So we can equate the log terms. So that's the equivalent of having 100x cubed equaling x to the 5. Divide by x cubed, we get 100 equal to x squared. Take the square root, I get plus or minus 100. So x is equal to plus or minus the square root of 100, I should say. And x is equal to plus or minus 10. But again, if we check the domain of the equation I'm looking to solve, x has to be greater than 0, which means x equal to positive 10 is the only feasible solution. All right. Down to C, similar process. Okay, we'll bring the 2 into the power. We've got a difference there. Notice the 3 is inside the log expression there, so we'll just leave that as it own. We can't muck around with that in terms of a power. So left-hand side, I'm going to end up with the natural log of x plus 2 all squared over x because there's a difference, which is equal to the natural log of 3x minus 3 if I multiply that bracket out. Again, log terms on the left and the right, so we can equate the expressions inside. So I end up with x plus 2 all squared on x equal to 3x minus 3, multiplied by my x across. And expand on the left, I'll get an x squared plus 4x plus 4 equal to 3x squared minus 3x. What are we going to do? We're going to group our x squareds together. I like to keep the coefficient of x squared to be positive, so I'm going to take everything to the right-hand side to leave me with 2x squared minus 7x minus 4. A little bit of cross method there. 2x and x, 2x times x is the factors of the first term. 1 times negative 4 is what I'm looking for the factors of the second term. I'll just follow down the line there. 2x times negative 4 is minus 8x plus x times 1, which is plus 1. So it gives me a negative 7x, which is my middle term. So I end up with a 2x plus 1, x minus 4 equal to 0. So x is equal to minus a half and x is equal to 4. But once again, check the domain. And for all of those to exist, I need x to be greater than 1. And so x equal to 4 is the only solution there that satisfies that. Okay, D is a little bit different because if you're not careful, it looks like we can just bring the 2 out the front, but we can't. It's the natural log, sorry, it's log base 4 of x all squared with a 2 out the front. So in actual fact, it's actually a bit of a quadratic expression because we've got a log base 4 of x to the power of 2, as opposed to log base 4 of x squared, which is just the term being squared. So if I put u equal to log base 4x, look, I've been a bit sloppy there, haven't I? So what if I just tidy these up as we go? They should all be u, shouldn't they? If I put u equal to log base 4x, come on, catch up. Sorry about that. So I get a 2u squared equals 3 minus 5u, because I'm going to bring that 5 out the front there this time. Okay, so I get u equal to log base 4x, which means I get 2u squared plus 5u minus 3 is equal to 0. So factors of the first term, 2u and u. Factors of the second term, negative 1, 3. 2u minus 1, u plus 3. So we get u is equal to a half and u is equal to minus 3. Now I substitute back for the u term, which is log base 4 of x. And I guess really I've taken a bit of a shortcut here by using my base transformation rule. So we know that if y equals a to the x, well then x equals log base a y. Okay, so that's what I've done. So the base is 4 to the power of a half is equal to x. 4 to the power of minus 3 is equal to x. So we can see that first solution there, 4 to the half equal to x, therefore x is equal to 2. And if we continue on my second solution here, I get 4 to the minus 3 is equal to x. So x is equal to 1 on 64. Okay, so check to see our domains. Both of them just require x to be greater than 0, so both of those solutions are valid. Slide into E now. Let's get my highlighter back. So again, what have we got? We've got the natural log of x. So I'm going to bring the 2 into the power. So, and then again, I've got natural log on one side, natural log on the right-hand side, so I can equate the expressions. So x is equal to 2 minus x squared. Expand for, a squared minus 2ab plus b squared, and group my terms together. So x squared minus 5x plus 4, factorising to leave me with x is equal to 4 or 1. But again, in the second expression there, I'm going to need x to be less than 2. Because at x equal to 4, I get 2 minus 4, and I can't work out the natural log of negative 4. So that only leaves me with x equal to 1 to be a valid solution. F is similar to the one we did in D, where I've got log base 2 of x all squared. So if I put u equal to log base 2 of x, I end up with u squared minus 3 minus 2u. So a u squared plus 2u minus 3 equal to 0. Factorise, I get u plus 3, u minus 1. So u is equal to negative 3 and 1. So again, log base 2 of x is equal to negative 3. Log base 2 of x is equal to 1. So again, I've used the log base transformation, I guess. So if we look at the blue one, 2 to the power of negative 3 is equal to x, which is that expression. And then 2 to the power of 1 is equal to x. So I get x is equal to 2 to the minus 3, which is 1 over 2 cubed, which is 8, and 2. Again, as long as x is greater than 0, both those solutions are valid, so we can keep both of those in. Multiple choice. What have we got? We've got f of x equals 3, natural log of 2x. Now, if f of 5x is equal to natural log of y, then, all right, so let's work out what f of 5x is, if I substitute it into my function, that's the same as 3 a log base e of 2 times 5x, which is log base e of 10x to the power of 3. The left-hand side, f of 5x is equal to log ey, so I can put log ey on the left-hand side equal to log e 10x to the power of 3. So again, I can equate expressions, so that means y is equal to 10x to the power of 3, which is 1000x cubed, which is e.